Well, hello everyone, and thanks for joining us today. Our topic is safety in transit. We'll be talking about how you can consider securing your data in your enterprise integration platform. So before we get into the content, let's talk about what we're actually referring to as an integration platform. These come in several different flavors. I'll look at three primary flavors. The first is iPaaS. This is the Gartner term, integration platform as a service, and that's the category that Flowgear fits into. So these are tools that are generally going to be cloud services. They're going to take care of processing integration workload in cloud. And as a customer, you're not really going to have to manage any of the upgrading, patching, or high availability. Then you've also got the enterprise service bus. These are tools and platforms that have been around for quite a bit longer. You're going to find them in a lot of very large enterprises where there's a focus on high volume of data, perhaps especially low latency, or very sensitive payloads that need to be processed. And then more broadly speaking, you've got integration or enterprise integration platforms as well. So think about in an organization where the threats come from a data perspective. There's a lot of focus on breaches of services like password providers or data that's been accidentally uploaded to a cloud provider without an authentication key. It's publicly exposed to the internet, or social engineering attacks where people accidentally give out information or have malware loaded onto their machines. But one category that's not very often considered is the risk that an integration platform actually poses if it's not being secured correctly. Now, think about it. If your ERP or your CRM is compromised by an attacker, then that attacker has access to those systems. But in an integration platform, any compromise there, in theory, means that an attacker could access any of the data that that platform is processing or the endpoints that it connects to. So the scope for an attack is actually far broader than any one individual platform or service. So hopefully that makes a strong case for why it's important to consider how an integration platform should be secured. So how do we deal with security? Well, you've probably heard this saying before, but it needs to happen in layers, and that is can be looked at from a few axes. In the one sense, you want to work from the outside or the edge in, or from the inside out. In another sense, you want to look across different departments and disciplines. So there's kind of many aspects to it. But what I'm going to share with you today are some key areas that you can look at as a starting point to be on your journey to ensuring that the way that you're managing data in your integration platform is secure. And ideally, what you want to do is kind of level up the way that you're handling a particular aspect, get that implemented, and then consider what the next step that you need to take is. So from a security and kind of threat management perspective, you want to continuously have a list of all of the threats that you feel are the largest risk to your organization or your data. And then you want to sort those by the likelihood or the impact of that risk and just keep working your way down. So security, like many things, is never done. It's something that's incremental, and figuring out how to triage and prioritize the level of risk is a very important aspect. So what we're going to look at is 5 different areas that you can consider around your integration platform to make sure that it's operating in a way that's secure and compliant from a governance perspective. First of all, we'll look at user access. How are people logging into the integration platform? Then we'll look at credentials. How is the platform itself storing credentials and sensitive information that it needs to be able to connect to different apps and services? Then we'll look at the environment that the platform is running in. Is it based on cloud? Is it in your own data center? And what do the host servers look like, and how are they separated from other types of workloads? Then we'll look at activity logs and the potential to store sensitive data there accidentally, and how to balance that with the ability to still troubleshoot. You need logs to be able to do that. And then finally, we'll look at change management. So in the same way that security is never done, integration is often never done, right? You're going to continue to make changes in your integration strategy, build features, change business logic. And so how do you manage the safe deployment of new changes and features into your production environment and ensure that there's an appropriate chain of custody along that journey? So let's start out with user access. So what we're talking about here is, how does someone go about signing into the integration platform itself? Now, if you think back a decade or two, if you wanted to allow people to log into the product that you were building, you get a username and password, you'd store them in a database, and then when they try and sign in, you just do a quick lookup on the username and password and figure out whether they match or not. And of course, we quickly realized that that means that if a third party has access to the database, then they can see the passwords. And so we started hashing passwords. Every vendor would have started doing this a decade or two back. And what that means is that even if access to the database is compromised, at least all that the attacker comes away with is a hashed password. But the problem doesn't really stop there, because the hashing technique that you use over time is going to become more and more or easier to crack. And so you have to use a hashing technique that's appropriate based on where kind of average compute performance is at. And identity goes way beyond just handling the login. And so for all of these reasons, managing user login is not just about authenticating a password. It's best to use an external vendor. So ideally, you want your integration platform to hook into a third-party vendor who specializes in this. There are many products available, but probably the two most popular vendors there might be Microsoft and Google, because they've certainly made science out of how to manage this. So if possible, switch your platform out to stop doing its own credential verification for users signing in and move it across to a Microsoft or a Google ID or a third-party authentication provider. And the reasons for doing this and the benefits are manifold. First thing is that your users are now going to have a single login that they're using, not just in your integration platform, but across all the other apps and services that are integrated with the same vendor. And so they're not trying to manage multiple separate credentials that don't really have any bearing on each other. They're therefore more likely to have stronger passwords, etc. You can enforce a second factor, or at least a multi-factor authentication. It might be SMS. Hopefully it's an app running on a phone or some kind of biometric or hardware kind of ID. But the point is that you can enforce that, and you can enforce it consistently, not just across your integration platform, but across all of the apps and services that your employees are signing into. Another key aspect is that you can enforce all sorts of policies around how people are able to sign in. Maybe they're only able to sign in when they're connected to a specific VPN or network. Maybe you have a geo block, so you can only sign in if you're connecting from a particular territory, or in fact from specific IP addresses that have been whitelisted. And that's just the tip of the iceberg. What does the reset policy look like? What is the rate limiting when there's a failed password attempt? What's the account lockout policy, and so on? And so all of these things are going to be governed correctly by an authentication provider. And finally, you have the ability to get an audit trail. So if there are failed login attempts or other suspicious activity that's happening, those audit trails, what's really important is that audit trail is tamper-proof. It's very hard to do that if you're authenticating into the integration platform and that's the thing that's generating the audit trail. You basically need the audit trail to be external to the service that's being audited. And if you're using a third-party auth provider, that's going to happen naturally for you as well. Now, we've looked at how users sign into the platform, but obviously by definition, an integration platform needs to connect to many other different apps and services. So how does it do that? Well, it has to authorize access for itself into those apps and services. The most obvious way to do that is through a username and password. That's really not ideal for all of the reasons that I've outlined previously. So wherever possible, when you have a choice connecting into, say, a specific CRM or an ERP or an e-commerce platform, go with one of the more favorable authentication options instead. So slightly better than a username password would be a service token. Why? Because you can issue a service token independently of specific users. So you can have service tokens that exist in parallel with each other. Service tokens, in this case, that are created specifically for the integration platform. And particularly if you use a slightly more advanced form of a token, such as a shared access signature or SAS token, then you can also get really granular access. So you can guarantee that that token only has the minimum level of permissions that are required by the integration platform to fulfill the task at hand. So you're mitigating security. Usually tokens have an expiration policy or a token refresh policy. You can manage them centrally. Again, most products are going to provide some kind of audit trail so you can see the history around that. And then probably the best option is to use a concept called managed identity. This is not always going to be available, but what this does is it offloads the responsibility of authorizing the service from the integration platform and the endpoint, and instead it's managed by the cloud provider. So in Azure, for example, when you create let's say you create a SQL database, and then you create a server, a virtual machine that needs to connect to that database, you can inject an identity onto that server. And so when the app that you're running, the integration that you're running on that server spins up and says, hey, I have this identity, Azure actually validates that identity and either grants or denies access to the database that it's requesting. What's really nice about that is that the integration platform itself doesn't have to manage any credentials. You've actually completely offloaded that responsibility. So we've looked at what type of credential you should ideally be using. Now let's look at where you should be storing that credential. So obviously a red alert is an integration platform that's storing credentials directly in a database. That would be extremely unsafe. So here we need to look at two different combinations. You might have a cloud-based integration platform, or you might have an on-premise or in your own DC deployment of an integration platform. In the cloud scenario, you definitely want to use the appropriate service. So for Microsoft with Azure, that would be the Key Vault service, which is the way that you're going to manage secrets, sensitive tokens, and certificates. And then the equivalent of that under Amazon would be Key Management Service. So check that your integration platform is using one of those two if it's a cloud-based service. If it's self-hosted, it does get a little bit more complex, and there are many other solutions available, but one of the more robust and kind of for baseline simpler ways of doing this is to use the Windows Certificate Store. And so basically the platform should either generate or be supplied with certificates that are stored in the Windows Certificate Store. And those certificates are used to encrypt and decrypt credentials, which are then stored perhaps in the database, but in an encrypted form. What's notable about using the cert store is that the operating system is then responsible for figuring out who is meant to have access. And what's notable about certificates, and the reason that we use this all over the place, is it uses a form of encryption called asymmetric encryption. That means that you have a private and a public key, and it's kind of a one-way street. So you can actually use them in both directions. You can use the private key to encrypt, in which case you'd use the public key to decrypt, or you can do the reverse. But in this scenario, what you want is you want to use the public key to encrypt information such that only the private key is able to decrypt. And by using the Windows Certificate Store and the APIs that it makes available, you can ensure that only authorized programs are able to access the decryption keys, and even that is indirectly handled, by calling into the OS crypto libraries. So again, a really robust way of making sure that those keys are not accessible to anyone who's unauthorized. So we've looked at how users log into the platform, and we've looked at how we store credentials inside the platform. But let's consider where these workloads are executing. We've basically got two categories. We've got cloud integration platforms, and then we've got on-premise platforms. So let's start with cloud. The benefit of cloud, of course, is that it's super quick to get up and running. These platforms typically scale on demand. So if you have a high transactional volume that you need to process, it's going to do all of that without you needing to figure out how to scale it. Obviously, as a result, there's no on-premise infrastructure. The vendor typically makes guarantees around uptime. They have high availability guarantees. There's a disaster recovery environment. So hugely advantageous, but you are putting the processing of all of those workloads in the cloud. And so it's much harder to protect not just against accidental egress of data, but intentional or malicious egress of data as well. So, the platform has to process all of the data. It has to move through the integration platform in order to be processed and transformed. So in theory, if there's personal information in there, it's going to run through that environment. So important that you think about how it gets secured. A good thing to look out for here is to check with the vendor what their tenancy model is. If you have been working in tech for any length of time, you're no doubt familiar with Kubernetes and how it's been a game changer in terms of making it really easy to deploy scalable services, particularly things like microservices. The problem is that a lot of vendors don't correctly handle deployment for integration platforms. So Kubernetes is going to allow you to spin up containers. But if you're using containers as your tenancy model, that's not fundamentally a safe way to separate different tenants from each other. Now, a lot of vendors do this on citizen integrator platforms that are kind of end user facing. Some of the larger enterprise integration platforms aren't doing that, but those that are very cost effectively priced, one reason they're able to do this is because of the level of density that they're able to get off the host infrastructure. And they're only able to run that high density, in other words, a large number of tenants on that infrastructure, because they're using containers instead of entire VMs. The problem is a container is not actually a security boundary. There are numerous ways that you can break out of a container or at least affect performance in other containers. So make sure that you have an integration provider that's giving you a dedicated VM. That's the only model that's going to give you a high level of isolation from you versus other tenants or other customers that are running in that same cloud environment. Now, if you're running in an on-premise data center, Obviously, the big upside is that you can much more easily guarantee that data is not leaving your network. You can lock it down as much as you need to. The downside, of course, is that you mention your own infra. Interestingly enough, there is still a very similar concern. While your workloads may not be sitting adjacent to other customers per se, like they would be with a cloud-based provider, you still need to consider that those workloads are potentially hostile to each other. For example, if you have a single deployment of an integration platform, you're a multinational company, and you have different geos or different branches, or even just different departments, and it should not be necessary for one department's set of integrations to see another set, then how are you separating those workloads? Again, the only surefire way to get an appropriate level of separation is by using a virtual machine. Otherwise, someone designing these integrations with this particular intent in mind will actually be able to read and write data that's happening in other workloads that are meant for other areas. So beware of considering things like namespacing or partitioning into different like subtenants or sub-accounts. Generally, that's not a security boundary, and it's possible to connect across those. So if you do have different types of workloads that are running that you shouldn't be able to, they shouldn't be able to intermingle. Generally speaking, you want to keep them on separate clusters of VMs, even if it exists inside your own data center. So we've looked at the environment. How do we actually secure the servers on which these integrations and the data is flowing? But what about the edge? How do we control data that's getting into that environment in the first place? Now, this is particularly relevant if you're using a cloud service provider. What you definitely want is a web app firewall sitting on the front so that you can control the entry point of data getting into the environment. So what we're talking about here is how we secure access to the APIs. Typically, those APIs are going to be the endpoint that users are going to be interacting with when they're using a web app or a desktop app to make design changes to the integration or read logs or access credential information. And certainly, they're going to be the endpoint that is getting invoked when you're creating webhooks. So if your integration platform is providing an API gateway role, then the incoming requests are going to go through the web app firewall. So you definitely want to assess that that's in place. Check with your vendor exactly how they handle that firewalling. Is it a multi-tenant web app firewall? Is it set up for you specifically? And do you have flexibility around policies that you can apply around that? So is there a rate limiting policy that will help offset potential denial of service attacks? Just like we talked with the user access login, is there a way to prevent invoke of those APIs outside of a geographic region or outside of a VPN or network connection that you want it to be? And so there are many techniques that you can use with a WAF and with the rules and policies that allows you to apply to ensure that you have least possible access that is required in order for the platform to do its job. So let's look now at logs. Logs are good and bad. On the upside, the logs are going to give you a lot of diagnostic information when something's gone wrong. And often without the logs, it can be extremely frustrating trying to troubleshoot a complex issue because you simply have no data to figure out what's happened. So if you have an anomaly that's a kind of a 1 in 1,000, very, very difficult to try and troubleshoot that problem until it recurs if you don't already have logs. So there's a place for them, but the negative side is, of course, it's very easy to accidentally store sensitive creds in logs. And this is a very nuanced problem. Consider, for example, you have a platform that is making a web call. And it's making a web call to a REST service, and the REST service requires a token to authenticate. So you're providing that token to it. Well, how are you providing the token? Badly designed APIs don't necessarily manage it in the correct place. So for example, you might be providing the token in the query string instead of in the authorization header. Now, most platforms, any reasonable integration platform is not going to log the authorization header because it's known to be a sensitive header. It should basically never be logged. But is it going to know to not log the query string? Well, the query string might have other useful information in it. So if the API has been badly designed, and that's what the vendor requires, that you have to provide those credentials in the query string, you stand a very high chance of accidentally having it logged. Another situation we encountered very recently is a situation where the vendor had it set up so that the token was sent as an HTTP request header, but it was a completely non-standard header. API key or something like that. And so no platform is going to know that that's potentially sensitive information. That information is just going to get logged along with all the other safe HTTP request header. So it's a really quite a nuanced problem that you need to figure out, and you need to find an appropriate balance. But here are some guidelines and some kind of simple heuristics that you can use. First is, ideally, you want to turn logging off by default on production workloads, because you are connecting to production data sets. And so you normally want the logging to be by exception only. So in other words, if an error occurs, some logging should get done. So check whether the integration platform that you're using supports that mode. So on in dev test, on in UAT, but preferably turned off in production other than errors. Second thing is, does the platform allow you to change the log level? So in this unfortunate situation where there is an anomaly, you need to troubleshoot. You don't normally want to kind of restart the whole platform. So change the logging rule and then kind of do a restart. Does the platform allow you to change that rule on the fly so that you can start collecting specimen data? And if you can induce a recurrence of the problem, now you've got more extended log information to troubleshoot the problem that you're trying to look at. And then finally, an absolute must is that you do have the ability to redact data. So in the example that I just gave you of a REST service that you're calling into that unfortunately is using a non-standard header, well, as you're building that solution out, you are cognizant that that is sensitive data that's getting stored in there. So you should be able to redact that particular piece of information as you are designing that solution. Other obvious examples would be personal information, credit card numbers and so on. But sometimes the specific information that you want to redact is actually quite a technical thing. It's not necessarily just PII. So it is about finding a balance. It's very hard to do this perfectly. And the trade-off is the less you log, the harder it is going to be to troubleshoot. But try and find an appropriate balance based on the type of workload and the sensitivity of the data that you're processing. So finally, let's look at change management. So what this is really speaking to is, if you're implementing a CRM or an ERP, these things don't happen all that often. Ideally, if an organization goes to all the effort of changing their ERP, they don't want to do that again anytime soon, probably on the order of at least 5, maybe 10 years before they really have to do that again. And so the end products that an organization uses tend to be quite stable. Cloud, maybe not so much. It's usually much quicker to switch in and out various cloud services, but your core systems, ERP, CRM, e-commerce, and so on, those tend to be pretty stable over time. But integration is not like that, because anytime a new product is adopted or retired, or there's a business rule change, or there's a feature request, you're going to need to make changes to the integration. And if your platform is not allowing you to keep up with that, then it's actually retarding the innovation that your business is trying to make. So it's not a question of locking in a particular set of integrations. It's a question of supporting the evolution of those integrations over time so that they can stay in lockstep with what the business wants to achieve. And so because of that, the change management process is really important. So what do we mean by that? Is you're going to have an initial version of a solution that's deployed, but hopefully not too much later. There are some features or business rules that change, or perhaps there's a regression or an edge case that you need to accommodate. So you need a platform that allows you to operate against a dev test environment, make those changes and evolve them over time, and then push them into an evaluation area where a third party can evaluate whether those changes have been implemented correctly, and then finally into production. So here's kind of a template for what that would typically need to look like. And this kind of mimics what happens in software development. In software development, you work on a change in a branch in a code repository. Once you're done with those changes, you'll submit what's called a pull request, which allows your peers or a superior to do a review of the code change. And if they approve it, or if there's a quorum of approvers, then that code gets merged into the main branch. In other words, it's approved for production use. And so you want an integration platform that supports that kind of way of thinking about change management, so that the workflows are like that code asset. They evolve over time. You need to be able to track them. So what we see here on the left-hand side is the test version of this solution. It's sitting at version 3, and a whole bunch of changes have just been completed. What the implementer should then be able to do is publish those changes into an evaluation environment, for example, a user acceptance testing environment. A QA person or a QA team would then be able to take over that integration, review it manually. It needs to connect to a different set of endpoints. So the QA or the UAT endpoints, be able to run some test transactions, test for regressions and so on. And then if they are happy, they should be able to promote into production. So it's kind of a slipstream process where there's a continuous cycle that, over time, as you have hundreds of integrations, they're all running at all of these different stages or all in parallel. And this is what's really going to support your governance process to make sure that you've got a repeatable and safe process for deploying changes. You don't want to slow yourself down. You want to be able to respond appropriately when a requirement comes up, but at the same time, you need to have an appropriate level of governance and ensuring that there's a level of safety around how things make their way from kind of a dev test environment all the way through to production. So that brings me to the end. Hopefully that gives you some good pointers around concepts to consider around securing your integration platform. We've looked at user access. How do users access the platform? How do they sign in? We've looked at the credentials that the platform stores, where it should be storing them, how it should be storing them, and what type of credential to use. We've made some observations about the different types of workloads that can be run, where they're running in cloud versus the data center, what concerns you might have around that, and the fact that generally speaking, these workloads should be considered as hostile. We've looked at some logging options, how you can make your logging more appropriate and safe, and balance that with your ability to troubleshoot. And then finally, what a comprehensive change management process looks like, so that it doesn't hold you back in terms of design and evolution of your workflows over time. Well, thanks very much for joining us, and we'll see you next time.